Dear student, now let's see the topic of enantiomers and diastreiomers. Before this topic, we must know that molecular representation. There is a molecular representation. This molecular representation, actually, the two types of is there here studied. One is for that Fisher projection, another one is a Sahar's projection. Okay, so in the case of Fisher projection, for example, the CH3 OH H CH2 OH. So if like that the molecular represented, that is nothing but for the Fisher projection. So similarly another one example, there is a COOH and OH H OH H COOH. This also is a molecular representative of the Fisher projection. Okay. So then next there is a Newman projection. That is we will study that the conformational analysis. Okay, for that topic. Now the enantiomers and diastreiomers. In generally, the enantiomers only is for that in the optical isomers. Enantiomer is only for optical isomers, but in the case of diastereomer that is for both optical and geometrical. Yes, there is optical isomers and there is a geometrical. So in this both optical and geometrical isomers are under the category of diastereomers. So when that optical isomer saying diastereomers, when that optical isomer saying enantiomers. Let's see now. The generally the enantiomers, for example, in the case of the first example of here given CH3 OH H CH2 OH. This containing the one chiral carbon or the carbon name or asymmetric carbon or stereogenic carbon. Okay, so this molecule is a chiral. So chiral means that is occurred in the optical activity or it rotate the plane polarized right, whether that is a dextrorotatory or levo rotatory, that meaning clockwise direction or anti-clockwise direction. Okay, first of all we can go to that numbering from the Kahn-Ingold per log rule. The atomic number is the highest, that is for highest first priority. Okay, so for this carbon is substituted this oxygen, carbon, hydrogen. From here this oxygen is the highest atomic number, that's why it's 1. And see, here is a carbon and here is also carbon. There's the same atom is substituted. We can move to that next level. There's a next atom. Next atom here is 3 hydrogen, but here is 2 hydrogen and 1 oxygen. So that's why there is a this priority is a second. And this is a third priority because of hydrogen is a very lesser atomic number compared to that carbon. That's why there's a third priority, there's a fourth priority. So we already given in that video, in the fourth priority, if horizontal representation is occurred, the rotation 1 to 2, that is for clockwise. So the fourth priority, that is a horizontal manner. So that's why that's for L enantiomers. Okay, L enantiomer. Okay, now we put on mirror here, we can get CH3, this OH is reflecting here, and this hydrogen, here is CH2OH. So now this 1, 2, 3, 4, this rotation is a anti-clockwise. The fourth priority is a horizontal manner. So that's why there is a D enantiomer. Okay, so now this molecular representation and see this. This both as a mirror image to one to each other. So that's why the enantiomers are showing mirror image. So the D and L are separately saying there is a enantiomers. The combined meaning there is a L comma D, there is nothing but enantiomeric pair. Okay, enantiomeric pair. Okay, that's all. Okay, the next here there is a single carbon as a chiral. There is a single carbon as a chiral. If we see that a molecule containing more than one chiral center are with adjacent carbon. For example, COOH and there is a OH, COOH. Here this is a optical active tartaric acid because here there is a 2 chiral center, but it is a internal compensation, it's not possible. So here is numbering is 1, 2, the whole term as a 3, this is a 4. There is 1, 2 means there is a anti-clockwise rotation, but there is a fourth priority as a the horizontal manner. So that's why there is a D nature. So this is a 1, 2, and this whole term as a 3, this is a fourth priority. There is also there is a D nature. Okay. So now simply similar like a previous example, we put on the mirror here. What we get? Yes, COOH and COOH. Here is a OH, H. Here is a HOH. Now this carbon and this carbon, there is a L and L nature. Okay. So simply what we understand here? Yes, the D nature of isomers and L nature of isomers, these two, there is a mirror image one to each other. So that's why there is a enantiomers are showing mirror images. Okay. That is the most enough in this topic. The next there is a diastereomer. There's a diastereomer. These diastereomers are not in the mirror image. Suppose the question they have asking whether that given compound is a enantiomer or diastereomer like that. Okay, we can compare one compound to another. For example, there is a COOH, here is a OHH, here is a OHH, COOH. Amazing! For this compound, and there is a COOH, here is a OHH, here is OHH, COH. They have asking the question, these two compound are diastereomer or not, like that. Simply we have answer. Actually, this compound is a previous example. Okay, so this is a D nature, this carbon also D nature, so that's why there's a D comma D compound. But in the case of this compound, this similar like representation here also, so that's why there's a D, but it is a L nature because it's a opposite representation of this carbon and this carbon in the two molecule. Okay, so that's why there's a D comma L. Now if you think about the D comma D, after put on the mirror, there is a L comma L, that is enantiomer. But in the case of here, D comma D, here there is a D comma L, these two not in the mirror image, so that's why that is a diastereomers. Okay, not in the mirror image. Wherever that organic compound, the configuration not in the mirror image, are simply finding that a dextro or a lever rotatory. After that mirror image, they have, if it's opposite configuration, that is a enantiomers. Any one carbon, if it has the same rotation, that is for diastereomers. So that's why these two are that, what the category? That's a diastereomeric category. Okay, the next we can go to that identical. For example, there is a CH3, here is a OHH, and CH2OH. For this chiral carbon, see that's a CH3 and here CH2OH. There is a above the plane OH and below the plane hydrogen. And another one isomer of this compound, there is CH3, here is CH2OH. There is a above the plane as a hydrogen, below the plane as a OH. So that is for flying wedge method. Okay, so now we know this molecule has the rotation as L configuration. This is a L configuration. Okay, so this 1, 2, 3, 4, this is the clockwise, but the fourth priority as what manner? That's a horizontal manner. So that's why there's a L configuration. So here which one is a identical or which is a identical? Okay, so from this compound and compared to these two, which one is identical? Now this is a 1 and this 2, this 3, this is a 4th, and here 1, 2, 3, 4th. So now we know that in the flying wedge method, the least priority or lowest priority are given the numbering least that group or atom. If there is a below the plane, means that is a most predominantly whatever that rotation, that is a the molecule, whether there is a clockwise or anti-clockwise, depends on that dextro or lever rotatory. See here there is a 1, 2, 3, so that is for the clockwise. The below the plane means we doesn't change, there is a D nature. But in the case of there is a fourth priority as above the plane, we can interchange, that's why there is a L nature. So compared to here, this compound and this compound, that is a enantiomer. Okay, simply there is a V or first compound, there is a for second compound, this is for the third compound. This first compound and second compound, first compound and that second compound are what? Enantiomers. Okay, enantiomers. And that first compound and that is a second, third compound, that's for identical. Then another one relation, there is a second compound and third compound, what? There is a enantiomers. Okay, very good, thank you. That's all. That is a most very easy topic, very easily understood this concept. Mostly 99% this optical active or enantiomeric topic is covered. Surely this topic is asking the NTA in that question. Okay, if you like this video, you can subscribe and share your friends. Okay, thank you to all.